So 5th year summer test, question 3, part A. Find the coordinates of the local minimum A and the local maximum B of the function that is given. Okay, so there's the function, and there's just a rough sketch of the graph of the function, and we're looking for the minimum point and the maximum point. Okay, so when doing this question, the method for this, okay, so you differentiate, you let the differential equal to 0, and you solve, and you find your values for x. You go back and find corresponding values for y, and then you find d squared y dx squared, and you see when you put in your x value, then you decide whether your point is maximum point or a minimum point. Okay, so and starting off here, so f of x the same as y is equal to x plus 2 all to be squared by 5 minus 2x. Okay, so to differentiate this particular question, it's a u by a v. Okay, so it's a product rule. So u is equal to x plus 2 all to be squared, v is equal to 5 minus 2x. And so differentiate du dx, we're going to use the chain rule, so we're going to bring our 2 down in front and multiply it 2 by x plus 2. Take 1 from our power, so take 1 away from 2 and you're left with 1 by the differential of what's inside the bracket. When you differentiate x, you get 1. When you differentiate 2, you get nothing. So du dx is equal to 2 by 1 is 2 by x plus 2. And to finish it off, du dx is equal to 2x plus 4. Okay, so over here dv dx is equal to minus 2. So dv dx is minus 2. So dy dx for the product rule is u dv dx plus v du dx. So dy dx is equal to u, which is x plus 2 all to be squared, by dv dx, which is minus 2, plus v, which is 5 minus 2x, by du dx, which is 2x plus 4. Okay, so dy dx is equal to x plus 2 by x plus 2 multiplied by the minus 2, plus we have 5 minus 2x by 2x plus 4, and to multiply that out. So dy dx equals, leave the minus 2 to the very end, so minus 2 into, you're left with x squared plus 2x plus 2x, which is plus 4x plus 4, plus 10x plus 20 minus 4x squared minus 8x. So 10x plus 20 minus 4x squared plus 8x. So dy dx is equal to minus 2x squared minus 8x minus 8 plus 10x plus 20 minus 4x squared minus 8x. So dy dx is equal to, you have minus 2x squared and minus 4x squared is minus 6x squared. And you have minus 8x and minus 8x, which is minus 16x plus 10x, which is minus 6x. And then you have minus 8 and plus 20, which is plus 12. So that's your dy dx, okay? So now what you do is you let dy dx equal to 0, okay? So you solve. So you take your differential dy dx and you let it equal to 0. So you have your 6x squared minus 6x plus 12 equal to 0. First thing I'm going to do is I'm going to divide across by minus 6. Okay, so I can do this because it's equal to 0. So that's x squared, and it's going to be plus x minus 2 is equal to 0. So to factorize that, x and x, we have 2 and 1, and we have plus 2 and minus 1. So x is equal to minus 2 and x is equal to 1. Okay, so the next thing that we want to do is we want to find our corresponding values for y. Okay, so we know that y, or f of x, was equal to x plus 2 all to be squared by 5 minus 2x. So y is equal to x plus 2 all to be squared by 5 minus 2x. Okay, so I'm going to let x equal to minus 2. So y is equal to minus 2 plus 2 squared by 5 minus 2 by minus 2. Okay, so y is equal to minus 2 by minus 2, so it's going to be 0 by 5 plus 4, so y is equal to 0. So that first point is minus 2, 0. And over here you have y is equal to 1 plus 2 squared by 5 minus 2 by 1. So y is equal to 3 squared by 5, take away 2, which is 3. So y is equal to 9 by 3 is 27. So that point is 127. Okay, so now we have our two turning points. One of them is A and one of them is B. So now we have to determine, you can pretty much tell that this point here, 127, is your maximum turning point, is point B, from the size of the y value, and this here is your 0. But best to go on and find d squared y dx squared. Okay, so how you find that is you take your dy dx, which is minus 6x squared minus 6x plus 12. Be sure not to take the one that was divided across or simplified. Okay, so d squared y dx squared is equal to minus 12x minus 6. Now just going to take the two value, or the 2 points, or the two x values, x equal to minus 2 and x equal to 1. So d squared y dx squared is equal to minus 12 by minus 2, take away 6. So you're going to be left with 24, take away 6, which gives you a value of 18, which is greater than 0. So I'll come back there in a second. D squared y dx squared, which is equal to minus 12 by 1 minus 6. So minus 12 minus 6. So we're getting minus 18, and that's less than 0. Okay, so when you look at what you've got from your d squared y dx squared, 18 is greater than 0. It definitely, the two values are very much different, an 18 and a minus 18. So this here is going to give you your minimum turning point. So therefore it occurs at minus 2, 0. So that there is point A, and your maximum turning point occurs when d squared y dx squared is negative. So that's your maximum point, which occurs at 127. So that is the point B. Okay, so the second part of part B of this question continues directly on from this, and it's asking to find the point of inflection. So point B there, or part B, is to find the point of inflection and to put it on the diagram. Okay, so how you find the point of inflection is very easy. You take your d squared y dx squared and you let it equal to 0, you solve it. So our d squared y dx squared, which we found from above, was minus 12 x minus 6, and we'll let it equal to 0. Minus 12x is equal to 6. My x is equal to 6 divided by minus 12. X is equal to minus a half. So what you do then is you find your corresponding y value. Okay, so you're asked to find the coordinates of the point of inflection and mark it on the diagram. So y is equal to, or f of x was equal to x plus 2 all to be squared by 5 minus 2x. So everywhere we see x, we put in minus a half. So we have minus a half plus 2 all to be squared by 5 minus 2 by minus a half. So y is equal to, so that's going to give you 1.5, or 3 over 2, all to be squared by 5, and minus 2 by minus a half is going to give you plus 1. So it's going, y is equal to 3 over 2 squared by 6, which is going to give you 9 over 4 by 6, which is going to give you 54 all over 4, which breaks down to 27 over 2. So our point of inflection, and that's just for the purpose of the diagram, is 13 and a half. So our point of inflection is going to be minus a half and 27 over 2, or 13 and a half. Okay, And so back to the diagram to put in the point of inflection. The point of inflection is where the curve changes from being concave upwards to being concave downwards. Okay, so where the curvature of the function changes. So we're talking about right here in the center. So it is minus a half and 27 over 2, or 13 and a half. Now part C of this is asking us to find the equation of the tangent at the point of inflection. So it's asking us to find the equation of the tangent. So the tangent, the line that passes or just hits the curve at one point. So that's what we're being asked to find now, the equation of the tangent at that point. So part C. So to find the equation of a tangent, we need a point and we need a slope. Okay? So in differentiation, we know that the slope is equal to dy dx. Okay? So the slope is equal to dy dx, which we already know. We already know that dy dx is equal to minus 6x squared minus 6x plus 12, okay? And we know that our x value is x is equal to minus a half. So to find our slope, dy dx is equal to minus 6 by minus a half, all to be squared, minus 6 by minus a half plus 12. And we find that our slope is going to be minus 6 by a quarter, and then that's going to be plus 3 plus 12. So dy dx is going to be 27 over 2. And remember, dy dx is the slope. So the slope of our line is going to be 27 over 2. So we take our point of inflection, because that's the point at which the tangent, we're looking for the tangent through the point of inflection. So our point is minus a half and 27 over 2, and our slope is equal to 27 over 2, and we just find the equation of a line. So y minus y1 is equal to m into x minus x1. This is your x1, your y1, so it's y minus 27 over 2 is equal to 27 over 2, which is the slope, into x plus a half, okay, because it's minus a half. Going to multiply across by 2, so 2y minus 27 is equal to, the 2 is going to cancel here, so 27 into x plus a half. X plus a half, okay? So you're going to have 2y minus 27 is equal to 27x plus 27 all over 2, multiply across by 2 again, so 4y minus 54 is equal to 54x plus 27. And I'm just going to rearrange it, so 54x minus 4y, now we have plus 27, and when I bring over the minus 54 it becomes plus 54, so that's going to be plus 81, and that is the equation of the tangent at the point of inflection, 54x minus 4y plus 81.